In today's data-driven world, organizations across all industries rely heavily on database management systems to store, manage, and process vast amounts of valuable information. Among these systems, Microsoft SQL Server stands out as a leading relational database management system, renowned for its robustness, scalability, and comprehensive features. From powering mission-critical applications to supporting business intelligence initiatives, SQL Server plays a pivotal role in the success of countless organizations globally. At its core, SQL Server provides a structured environment for storing data in interrelated tables, enabling efficient data retrieval, manipulation, and analysis. Its ability to handle large volumes of data with high performance and reliability has made it a popular choice for enterprises of all sizes. Moreover, SQL Server offers a wide array of security features, ensuring data integrity, confidentiality, and availability. The widespread adoption of SQL Server highlights its critical importance in modern business operations. As organizations increasingly rely on data-driven decision-making, the security and integrity of their SQL Server databases become paramount. Any compromise or unauthorized access to these databases can have severe consequences, including data breaches, financial losses, and reputational damage. This is where the specialized field of SQL Server forensics comes into play. Just as traditional forensics focuses on investigating physical crime scenes, SQL Server forensics delves into the intricate world of digital data stored within SQL Server databases. The SQL Server forensics plays a crucial role in both data recovery and incident response. In the unfortunate event of data loss due to accidental deletion, hardware failure, or software corruption, forensic techniques can help recover lost or corrupted data from SQL Server databases. By analyzing database backups, transaction logs, and other artifacts, investigators can piece together fragmented data and restore it to a usable state. Beyond data recovery, SQL Server forensics is essential for investigating security incidents and cybercrimes. When a security breach or suspicious activity occurs within a SQL Server environment, forensic investigators can analyze system logs, audit trails, and database artifacts to determine the extent of the incident, identify the attacker, and understand their tactics, techniques, and procedures. This information is vital for incident response, remediation, and future security enhancements. SQL Server forensics is particularly relevant in investigating insider threats, where malicious or negligent employees misuse their authorized access to sensitive data. By examining user activity logs, database modifications, and other forensic artifacts, investigators can uncover evidence of unauthorized data access, modification, or exfiltration. This evidence can be used to support disciplinary actions, legal proceedings, or insurance claims. The findings of SQL Server forensics investigations are often used as evidence in legal proceedings such as civil litigation, criminal prosecutions, and regulatory inquiries. As a result, it is crucial that forensic investigations are conducted with the utmost care, adhering to legal and ethical standards to ensure the admissibility of evidence in court. In SQL Server forensics, understanding residential and non-residential artifacts is crucial. Residential artifacts reside within the SQL Server database files. They persist even after the SQL Server instance is shut down. Examples include data files, transaction logs, and the master database. Non-residential artifacts reside outside the database files. They are found in the operating system, application logs, and other system files. Examples include Windows event logs and SQL Server error logs. Volatile artifacts are temporary and can be lost if the system is shut down or restarted. Collecting these artifacts is time-sensitive and requires specialized tools. Ensure all actions are forensically sound to maintain evidence integrity. The data cache, or buffer pool, stores frequently accessed data pages in RAM. Analyzing the data cache can reveal recently accessed data. Another key artifact is the active portion of the virtual log files, VLFs. Examining active VLFs provides insights into recent transactions. Forensic investigators use live response techniques and specialized tools. Section 5. Gathering non-volatile SQL Server artifacts. Non-volatile artifacts persist even after the system is shut down. These artifacts are stored on disk and can be collected at the investigator's convenience. Primary non-volatile artifacts include database files like MDF, NDF, and LDF. These files contain data, transaction logs, and metadata. SQL Server error logs are invaluable sources of information. Analyzing these logs can reveal issues related to security incidents. Creating disk images ensures forensically sound copies of data. Securely store and document artifacts to maintain chain of custody. All right, let's move on to analyzing the collected artifacts. The analysis phase is where the real detective work begins. During this stage, forensic investigators examine the gathered data to uncover evidence of malicious activity, data breaches, or other security incidents. First, investigators will typically start by examining the database files. This involves looking at the data stored within the tables, views, and other database objects. By analyzing this data, investigators can identify any unauthorized changes, data exfiltration, or other suspicious activities. Next, the transaction logs are scrutinized. These logs provide a detailed record of all the transactions that have occurred within the database. By reviewing these logs, investigators can reconstruct the sequence of events leading up to and following a security incident. Error logs also play a crucial role in the analysis phase. As mentioned earlier, these logs contain a wealth of information about errors, warnings, and other messages generated by the SQL Server instance. By carefully analyzing these logs, investigators can identify any anomalies or patterns that may indicate malicious activity. Finally, forensic investigators may use specialized software tools to assist with the analysis process. These tools can help automate the examination of large data sets, identify patterns, and generate reports summarizing the findings. Moving on to the power of SQL scripts in automated data collection. SQL scripts are incredibly powerful tools that can significantly streamline the data collection process in SQL Server forensics. By automating repetitive tasks and standardizing data collection procedures, SQL scripts help ensure consistency and accuracy in forensic investigations. One of the primary benefits of using SQL scripts is their ability to quickly gather large amounts of data from multiple sources. For example, a well-crafted script can extract data from various tables, views, and other database objects in a matter of seconds. This can save investigators a significant amount of time and effort compared to manually collecting the same data. Additionally, SQL scripts can be customized to target specific types of data or artifacts. This allows investigators to focus their efforts on the most relevant information, improving the efficiency and effectiveness of the investigation. Another advantage of SQL scripts is their ability to perform complex queries and analyses that would be difficult or time-consuming to do manually. By leveraging the power of SQL, investigators can quickly identify patterns, correlations, and anomalies within the data, providing valuable insights into the nature and extent of a security incident. Finally, SQL scripts can be easily shared and reused across different investigations. This promotes consistency in data collection procedures and helps ensure that best practices are followed in every case. Finally, let's discuss the crucial role of SQL Server forensics in cybersecurity. In today's digital landscape, databases are often the primary targets of cyber attacks. As such, SQL Server forensics plays a vital role in identifying, investigating, and mitigating these threats. By thoroughly examining SQL Server artifacts, forensic investigators can uncover evidence of unauthorized access, data breaches, and other malicious activities. This information is essential for understanding the scope and impact of a security incident, as well as for developing effective strategies to prevent future attacks. Moreover, SQL Server forensics can help organizations comply with legal and regulatory requirements. Many industries have strict guidelines for data protection and breach notification. By conducting thorough forensic investigations, organizations can demonstrate their commitment to safeguarding sensitive information and meeting their legal obligations. In addition, the insights gained from SQL Server forensics can inform broader cybersecurity efforts. For example, by identifying common attack vectors and techniques, organizations can strengthen their defenses and improve their overall security posture. In summary, SQL Server forensics is a critical component of modern cybersecurity. By providing valuable insights into database-related incidents, it helps organizations protect their data, comply with regulations, and enhance their overall security.